We're going to get started. My name's Tom Zimmerman. I am with Cambridge Sound Management. We have recently been acquired by a company called Biamp, but I still prefer to say that I'm with Cambridge Sound Management because that's what I feel like what I do. We have been doing sound masking for since about 1999. Our company was founded by a couple of audio consultants out of Bolt, Beranek and Newman, BB&N, out of Cambridge, Massachusetts, who are also involved with the entire foundation of starting sound masking as a way to control privacy in open environments. So what we're here to talk about is why architecture is driving the need for sound masking. Again, what we find more and more is that it's open office environments. There are no carpets, there are no acoustic ceilings. We go straight to the deck. We have exposed HVAC ductwork. We have natural lighting so that you can get your lead points for when you're doing a building, so that everybody can see a window from wherever they are. And frankly, over 70% of offices have open floor plans now, and only 2% of those have sound masking in them currently, according to our research and the research of a few others. And we do find that sound masking is the most cost-effective solution for improving privacy and reducing distractions in the open office environment. And we'll go through why that is. Basically, what we have is A, B, C, D. There's actually an A, B, C, and a D for why you want sound masking in your building. A is for absorption. Absorptions are things that are fuzzy, things like carpets, things like acoustic tile ceiling. And what we are doing is we're pretty much eliminating absorption from most of the open office areas. B is for blocking. Blocking is partitions, is walls, is doors, is anything that's hard. And we're pretty much removing all of the things that block sound from going from space to space. C is for covering. Covering is what we do. Covering is any sort of background noise. When you talk about building an NRC rating for a conference room or something like that, what you're talking about is what is the level of the background sound in those spaces. And what we do is we go and we raise that background noise level so that it makes it easier for people not to be distracted. D is for distance. Again, what we find is that more and more you put more people closer together, you don't spread them further and further apart. There's something called the inverse square law where you lose 6 dB of noise for each doubling of distance. So if I go from 15 meters to 30 meters, I lose 6 dB of sound. So that's why we say distance is your greatest friend, because the further away you are, the less likely you are to hear things. So the case for acoustic privacy. I love this. I'm going to read it to you. I currently work in a cubicle. My neighbors are a man in the midst of a divorce, a woman with a problem child, another woman with an elderly parent who should be in a care facility. The only cure for my personal hell would be a quiet room with a door. Perhaps my employer would then get his money's worth from my workday. Did I mention that I'm across from the copier? This is what we're finding more and more. So they do surveys like they do with everything else. And when they survey people in open office environments, generally people are satisfied with maintenance, layout, furnishings, thermal comfort. Nobody's ever happy with thermal comfort. Everybody wants their own thermostat. But again, it's not the worst thing. The worst thing is acoustic privacy. Nobody thinks that they get the privacy that they deserve sitting in an open office environment. So again, we're going to go back to the basics here. What we have done is, if you grew up in my generation, you had partitions, you had cube farms, so you had partitions everywhere that blocked you from the people around you. And so this blocking sort of was your privacy mechanism. So what we are doing now is we're kind of taking down all that blocking. We're making so people can see the windows, so that people can collaborate. More and more we hear everybody's got to collaborate. You got to be able to talk to your neighbors. You got to be able to discuss things with everybody around you. Okay, so now sound can travel unimpeded through the space. We've taken our acoustic tile ceilings. we used to be able to have some acoustic tile that would absorb some of the sound. And when you have absorption, the sound that hits it is less when it gets to the next person on the bounce of that sound. So we take away the acoustic tile ceiling. We now have a hard reflective ceiling, the deck basically of the floor below or the floor above you. Sometimes you spray it with some acoustic material, sometimes you put fire retardant, sometimes you put other things that can absorb some things, but not as much as an acoustic tile ceiling. So now sound is directly reflected back up and down. You also put in glass. Now everybody can see a window, so you have this new reflective surface glass, which is not very absorbent. And so you have this hard surface, and so now people hear more and more things bouncing off the glass as well. So the sound builds up in these spaces. Then you have the worker distance. You used to have people basically in an 8x8 cube, maybe a 10x10 cube if they were really lucky. And what we do is we take all of those people and we shift them closer and closer together so that now the worker distance is basically, one person for every 10 square feet instead of 100 square feet. So again, that's what's happening here. Then we have covering in an open office environment. People that have already installed sound masking, you put the little cans. In this case, this is the style where it bounces off of the deck above and comes down and covers the people. Again, very effective, and if you install it correctly, and we'll get into how we do that, it works nicely to make it so that people can't hear exactly what the other people are saying. Private offices, the same sort of thing is taking place. You used to have nice, thick, usually double gyp walls with furring in between, some space gaps, maybe even filled with some fiberglass. And what we're seeing is, first we went and said, well, we're not going to take those walls all the way to the deck. We're going to, because it's a lot cheaper, we're going to just build them up to the, just above the finished wall. Then what happens is that we have the sound that bounces over top of that. So people are now hearing directly from the offices next. So you still have a little bit of sound that's, taken away, but you have a lot more that just is bouncing over the top. We found that, you get tax credits and other things for putting demountable walls in instead. And facilities people love demountable walls, because then if you decide to go and rearrange the layouts, if you want to do other stuff, you have these demountable walls, you just take them out. You want to turn this private office into an open office, that's great. This is really easy. The problem is that with demountable walls, they're not as thick. They don't block as much sound going between them. So again, you get more transfer from one person to the other. You have sound leaks at the top and bottom. Usually you have gaps of some sort if the furring isn't done just right. If you don't seal them properly, you have a lot of sound that gets transmitted right over the tops of them. Plus the stuff that goes just over the top naturally. Also in private offices, a lot of times you have the electrical receptacles back to back on each other. So when you have that happen, sound leaks around those. If you have any ductwork that has penetrations, it goes right over through those too. And if you have ductwork that's not properly fitted, that doesn't have baffles in it, that doesn't have other things, you have an instant intercom that goes between all of those offices. So again, we normally get calls from people saying, it's as though there isn't even a wall here. And I go in and I look and I said, well, there really isn't a wall there anymore. It's all just an acoustic nightmare. So we're going to look at types of sound masking. Again, I don't know why this guy's always on his toes, but he is. And he's a happy guy. So we put up the sound masking, and in this case it's called an indirect system. Indirect means that you can't see it. It's above the finished ceiling. Okay? So a lot of architects in particular don't like to see anything on their ceilings. Interior designers don't like to see things on their ceilings, even though there's hundreds and hundreds of WAPs and LANs and other stuff that's going on. They don't like to see speakers on the ceiling. So we put it up above the ceiling, and again, we bounce it up off of the deck above. It comes down, it filters down, works great. And we can design these systems as long as we know what that ceiling material is. The reason we need to know that is if it's fiberglass or something that's very could be absorbent, but not very reflective, doesn't have a good CAC value. If it doesn't have that, then it tells us that we need to space speakers closer together. If it has a high CAC value, like mineral tile or something else, then we can space the speakers farther apart because it does more bouncing up and down between the deck and the material before it filters down. So our loudspeaker distance is all based on what that material is, how high the ceiling is, ceiling height, plenum depth. We need to know all those things in order to design an effective system. Our company has a patented system that we call the direct field. So we have little tiny speakers, 3 inches, that go actually firing down or mounted into the acoustic tile ceiling, in this case. And it allows us to exactly know what it's going to sound like when we install it. And I'll get into why that's important in just a bit. So if we know the ceiling height, we know exactly how many speakers you're going to need. 8-foot ceiling, an 8x8 grid. 10-foot ceiling, 10x10 grid. 12-foot ceiling, 12x12 grid. The higher you put them, the less speakers you need because of the coverage of each speaker. You can also go and mount these direct things onto either the truss or the deck itself or the other things. We have all sorts of mounting options where you put them on pendants, whatever you want. But again, you get them up higher, you need less in an open deck ceiling. But again, in this case, we're firing directly down. We know exactly how it's going to sound. So as long as if the emitter height goes up, you need less speakers. The indirect, again, when you have an open ceiling, when you're not doing it in a plenum space, again, it's just a one bounce up, it comes back down. You need more speakers when you don't have that area for it to bounce around up there. So if we know the duct height, we know how many speakers you need. Underfloor, many people haven't ever even seen an underfloor system. You know, the old dinosaur rooms where they used to have the computers, where everything was raised floors. Well, they still have a lot of those in particularly old bank buildings, old finance buildings and that sort of thing. Places where they used to have big computers that they don't have computers anymore. So you can actually put these under the floor, have it go bounce around in that underfloor plenum space, and then come back up. Loudspeaker distance, again, is based upon mostly what type of floor material they're using. There's a lot of places that have decided to use like concrete or structure wood products that basically you can't get any sound through. So once we know what that is, we can tell you whether or not it's even going to be a possibility. Okay, sound masking concepts. 5 things that you have to always think about for sound masking. Proper level. If you play it too loud, people are going to complain. It's annoying. It's not a good thing to have sound masking that's played too loud. A lot of places, they say, well, you know, I really don't care about my employees. We're just going to blast it at them. They will leave. They will absolutely leave. There's a very fine range of sound levels that you can use that people are comfortable with, that match the rest of the sounds of the building, that actually make it so that it's a comfortable place to be instead of an uncomfortable place to be, either because it's not loud enough or because it's too loud. And that's what we always shoot for, is you have to have it exactly right. The correct spectrum, we only mask human voice frequencies. We don't worry about like your high fidelity audio system kind of thing where you're going from 20 hertz to 20 kilohertz. We only care about masking the human voice because what we try to do is to mask the human voice. So our spectrum is very specific on how it's shaped, what it looks like. And again, there are a lot of acoustic consultants that like their particular shape. We are fine with that. We can adjust to any spectrum shape they want. But in general, right out of the box, most of our products will give you a recommended spectrum. Uniformity, that is going to be the thing we're going to focus on most during today's talk. So I'm going to skip that for right now. Occupant comfort. When you do sound masking, you find 2 things. One, there's bass frequencies and treble frequencies, right? And bass frequencies are mostly the sound of my voice. My voice is somewhere centered around 200 hertz or so. And you have treble frequencies like tss. your T's, your P's, your B's, your S's. Those are all your higher frequencies. And so what we try to do is to make it so that those particular consonant sounds are masked. Those are the sounds that make it so that you can understand people. So what we try to do is to make it so that those frequencies are covered, but those are also the frequencies that annoy you. Any of those high frequencies, like if you think about pink noise or white noise is a mathematical construct of the way of a spectrum shape, and it gets higher and higher in level the higher it goes in frequency. Those are the frequencies that really annoy you. So our shape is like this. We like to concentrate on the bass frequencies and then to have just enough of those high frequencies that could be annoying just to cover people's voices, not played so loud that it gets annoying. And if we do that correctly, then it's unobtrusive. If people walk into the building and they go, this is just the sound of the space. That's what we'd love to hear, is that if somebody goes and turns off the masking system, people go, oh my God, it's so quiet in here, I can't hear myself think. Or if the power goes out, they go to the sound masking system, they say, God, it's getting hot in here. Or, man, it's getting cold in here, because they think it's the HVAC. That's what we try to make it sound like, is that it's just a natural building sound. It's not something specific. It's not going to hurt anybody. It's only played at 48 dB. You're not going to go deaf. You're not going to have seizures. You're not going to have anything else. It's a very low-level sound. So, and in order to make that so that it works, is you need excellent uniformity. So what we have is what we call the radius of distraction. When I am talking in a normal voice, you can hear my voice about 45 feet or 4.5 meters from where I'm standing. So if I'm in any sort of standard office space, particularly one that doesn't have any sort of blocking or absorption in it, somebody 45 feet away from me can understand what I'm saying. And by adding masking, what we try to do is to get that down to about 15 feet or 4.5 meters. So that if I need to collaborate, if I need to talk to people face to face, if I need to hear somebody that has a question from 2 desks away, I still hear them fine. It's the people that don't need to hear what I'm saying about 15 feet away from me that can't hear me anymore. They can't understand what I'm saying. If they can't understand what I'm saying, then they don't pay attention. Humans are very specific. As they can understand what you're saying, they can't help themselves from listening. They cannot. And people go and they put on acoustic canceling headsets, like the Bose headsets. And what they find is that they have blocked out the constant noise, and now all they hear are the people talking. And so it's really, really annoying when you go and you buy these, $200 headsets, you put them on, you go, oh my, now I hear people better than ever. We still haven't figured out a way of canceling out human speech using a mathematical algorithm. Nobody's figured that out. What we've talked about is uniformity. Loudspeaker spacing. Again, we make a grid. We turn the entire ceiling into an array so that every single speaker is a part of the group. You don't notice any single speaker at all. There's no real loud speaker, there's no real soft speaker. The whole area sounds exactly the same. Variations in building material. We zone the system so that if there's a gypsum ceiling over here, there's an acoustic ceiling over here, it goes to the deck over here. There's a cafeteria over here where they want to do, say, town hall meetings or something. All of those areas are handled as their own zone. We never try to mix different acoustic type spaces together in a zone. This allows us to control each one and have exactly the right spectrum, exactly the right level for the entire space. That gives us the control that we need by having those zones. And interference. If you have 2 speakers that are next to each other and they're playing the exact same signal, there are frequencies that will add to each other, and there's going to be frequencies that cancel each other. So if you play the same sound through every single speaker in that grid, as you walk through the space, it's going to go whoosh, 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 because the speakers will be summing or canceling as you walk through, and that's how you know that the system has been designed wrong. What we do is we actually have 4 different masking generators, and each speaker gets its own masking generator, so there's never 2 next to each other that produce the exact same frequencies, because that's what causes interference. Masking myths. These are the things that you're always going to hear. HVAC noise is a substitute for sound masking. Well, it can be. If it's on all the time, if it has exactly the right spectrum, if it isn't too loud or too soft, if it never varies, it can work okay. In my time, I've found one office where the HVAC actually could be used as a sound masking substitute. All the rest either went on and off, or it was different by season, or it was different based upon, you know, over this section of the room was fine, but this section that you get away from a lot of the ductwork and stuff, it doesn't match the rest of the thing. So it's not uniform, it's not unobtrusive. Sound masking can reduce the noise, i.e. restaurants. We get a lot of calls from restaurants saying, people can't hear themselves in my restaurant. I want to put sound masking in. And I go, you don't. It's already too loud. We can't help it if it's already too loud. We come in at a very low level. And it's great for like a private office or an open office area, but we can't reduce the sound that's already in there. People are already talking at 70, 75, 80 dB inside some of these restaurants. You can't even hear the person sitting next to you. How can adding noise help that? Sound masking cancel sounds. Again, like the Bose noise canceling headsets. Actually, if we did cancel sound, you would still hear all the people's voices because we don't know how to cancel the sound of the human voice. Masking absorbs other sound. They think that if you put a speaker outside of a door, that it's going to absorb the people in the conference room talking, and when it comes through the door, it's going to be absorbed by the speaker that's outside the door. No, it doesn't do that. Once you get out from under that speaker that's under the door, get 10 feet out into the room, you're just going to be able to understand what the people are saying in the room. My wife and I were in the bathroom. She's taking a shower. I'm at the sink. I can't understand what's, the TV that's on in the other room. If I walk 10 feet away from the shower, all of a sudden I hear the TV again. Again, it's because it's distance and the level of signal that you're getting. Sound masking can block sound. No, for the same reason. It doesn't have any substance to it. The sound just goes through it. And it will prevent face-to-face communication. If it's designed correctly, it never prevents face-to-face communication. It's always played. It's a signal-to-noise ratio. I don't know if anybody's ever heard of that, but we always have at least 15 dB below whatever the human voice level is. The equipment, I said that one of the things that Cambridge Sound is known for is these little tiny emitters that go on the ceiling. What it allows you to do is if you just want sound masking in the open office areas, you just have it in the open office areas. Even though the walls don't go to the deck, even though there's all sorts of other things, if you want to have a private office over here, you play it at a different level through different speakers on a different zone. If you don't want sound masking in your little conference room over there, you don't have masking. For the direct field, again, it's a really simple system, very elegant layout. You take a single cat cable and you run it to the first speaker. You take another cat cable that we provide to the next, and it's just daisy chains. And as it goes from speaker to speaker, it actually changes which of the masking generators. So that's how we keep them from not having the same signal coming out of any single speaker next to another one. Key benefits: great uniformity, multiple signal generators, easier to install in existing construction. If you already have a place that has employees in it, this is a nice system to use. It's very easy to install. It's very labor cost effective. And you don't really need to tune it. It comes out of the box already pretty much ready to go inside these spaces. These are the equipment. We have different zones, so depending upon how much space you need to cover, if you only have one open office area, you can use a 1 zone. If you have a lobby area you want to do, an open office area, and some private offices, we have a 3 zone. If you've got a big floor that you want to do, we have a 6 zone. Very easy to control. You can just go to the front control panel, use little arrow keys, go to the zone you want, move it up and down. Quite simple. And again, it uses Cat cable. We actually provide Cat 3. It's not running Ethernet. It's running audio. So what we have is 4 pairs of audio cables that are going to the speakers. Okay? So it's not PoE, it's not any of those things. No, it's just a way of using audio and using a cable that everybody knows how to terminate, and most people know how to run safely from speaker to speaker. Back of the unit, again, multiple zones. You have different runs so that if you have a big open office here, you can start by taking one cable out to this area, one cable out to the other area. We have audio inputs if you want to add paging, if you want to add music, if you want to add bells. We have ways for you to do that. We have contact closures. Many jurisdictions require the sound masking to be muted when a fire alarm or other alarm condition happens. So we have contact closures that allow you to mute those things. We have an Ethernet connection. You can actually put this system onto your LAN or connect to it using a laptop to control it. This allows you to do things like an enterprise that has, let's say 100 of these units across multiple facilities. You can actually go and make sure that all of them are operating, to make sure there's no fault conditions, make sure that there's nothing else happening. There's a front panel lock so that if you do put it into an unsecure space, usually these go in an IDF or a data closet or a phone room or something like that. But if it's not a locked area, you usually want to lock the front panel so that somebody doesn't try to help themselves by going and just arbitrarily going and moving volumes up and down. I actually was recently doing a Google facility, and a guy came out and said, "I learned how your system operates and I changed all the levels." I said, "Good for you. Thank you so much." I'm sure Google will be very proud. So anyway, and a power connection. Again, it's a 24 volt power supply. This unit runs 360 speakers with 17 watts of power. It's LEED certified, it's very efficient, it does, no worry about extra power or voltage going through the system. This is the third-party interface, as I said. So if somebody does need a VoIP phone connection, generally we don't provide that VoIP phone connection. You'd have a VoIP converter box that would then feed ours. Ours is basically an amplifier, so whatever you connect to it, we'll just broadcast that through whichever zones you want. This is what the speaker looks like in situ. So it just sort of goes through an acoustic tile and you just screw it into the tile. Normally the cable itself is connected at the deck using J-hooks or something else, just standard cabling connections. And each of those cable connectors are actually rated to 9 times the weight of the unit, so they can actually hold up the rest of the ceiling just by having the speaker cables connected. That said, there is a dead man's hook on the back so that you could go and tie off each one if the jurisdiction requires you to have seismic ratings or other sorts of things. There's a web interface built into each of the boxes. This is how you would connect using the LAN. And so it's just a simple password that you use to get in, but we can set multiple levels of passwords. We can have different notifications with emails sent. We can do all those sorts of things that you expect from normal electronics to sort of watch out for the system and tell people if there's a problem. The other type of system, the out-of-sight system, again, you put your speakers up in the ceiling, you turn them on, they bounce around, they come back down. We call this masking for free, even though you really didn't want masking in this room because there's no walls, there's nothing to stop it. The sound doesn't know that you didn't want sound in there. So we have to be able to program these systems very well, have it tuned usually by our company, a professional tuner come in because I'll show you an example here. Obstructions in the plenum, air return grills, HVAC lighting fixtures, variances in ceiling height, all are interesting difficulties with these sorts of systems. When you turn on the system, you have I-beams that block the sound from going from space to space. If you have lights or air return grills, a lot of times there's perforations in the lights, or the air return grill is just an opening into the ceiling itself. And so sound doesn't know, it just comes out and it just dumps right down into the room. So again, being able to control systems like this is extremely important, and our system is actually able to control every individual speaker. So that if this particular speaker is egregiously bad and dumping sound, we can actually turn that one speaker down, we can change the spectrum, we can do all sorts of things to make it so that that sounds like every other speaker, even though it's right over an air return grill. 70-volt systems, this is what I call masking by the acre. This is what was originally the breakthrough product back in the 1950s and 60s, where you could add sound masking with huge racks of equipment and big amplifiers and stuff. And it was not really able to be uniform because you only had these little taps on the tops of the speakers that allow you to control them by 3 dB steps. We tried to keep a uniformity of plus or minus 1 dB throughout an entire building. These you control up to about 3 dB. It's got the equipment rack. Again, you put as many speakers on an amplifier as the amplifier can handle. So if you have 200 watt amplifier, you can put about 160 speakers on it. If you have a 600 watt amplifier, you can put about 500 speakers on it. So it's very efficient, but it's not very uniform. It is the lowest equipment cost. It's almost always going to be the lowest equipment cost. You have a centralized equipment location, easy to install during new construction because you can get your labor in there, hang all of the mounts and everything above, mount them to the deck actually before the ceiling grid even goes up and stuff. So it's very efficient from a labor standpoint, but it can also be the lowest performance. But we have clients that this is all they do. Some really big ones. Acres and acres of it. This is the other type of indirect. It's a network system. There's actually a controller. This is a PoE powered device. This controller has 8 amplifiers built into it powered by PoE. This is what allows you to control every individual speaker. So basically you run from a PoE switch in your LAN room and you go out to these controllers, and that's where the speakers are powered from. You have excellent uniformity. You can control every single speaker. You can reconfigure, like if you went and took one of those dirt walls or reconfigurable walls, blew it away, had it all open spaced, you just go back to the software and you can change what's happening in that space. Very good performance. Underfloor, again, I'm not going to dwell on this too much. I don't see that happening a lot, but we did just do a recent install here in Toronto that is an underfloor system, so it can be done here. And again, we just run speaker wire from that controller device, go back off to head-end location, and again, fairly uniform. There's a lot of penetrations when you have a raised floor. You have all sorts of things that you wouldn't think about, like HVAC ducts that penetrate there. You have all of your AC connections in the floor. So there's a lot of places for sound to just sort of leak out. So it's not quite as uniform as something in the ceiling. And it's easy if you get it in before the actual furniture comes in. This is what a 70-volt system kind of looks like. It's just got these speakers hanging on. You hook it up to the first speaker, and you just daisy chain speakers. It's really quite easy to install. And then we have all sorts of other ways of controlling it. Even though it's 70 volt, we can add different masking signals, so at least you don't have a lot of interference. This is the network system. Again, it's very flexible. You go to a PoE switch, You can add extra masking generators. It's got 4 masking generators in each one of those little controllers. It's got 4 more in extra DSP units. You can actually run 36 different channels of audio. So if you wanted a paging system that did just 1 speaker in the loading dock and 1 speaker in the kitchen area and 1 speaker in the security office, you can get to that level of granularity with the system. It's very, very sensitive. You put that unit up in the ceiling, you have 8 speakers that you can run off of each one of those devices. As you expand the system, you have the software that comes into your switch going out through your patch bay. And then you just go floor to floor. You can do hundreds and hundreds and hundreds of speakers, entire buildings. You actually have fiber connections so that if you want to page from one building to the next, you can just connect by fiber between them. It's quite a sophisticated little system, and all run off of a single touch panel. And if you want that touch panel on your network, you only have 1 IP address that you'd need to assign for hundreds and hundreds and hundreds of speakers. When we normally do the design, actually here in Canada, your distributor, Technik Contact, we're down in booth 705. Please stop by. Technik Contact has all the equipment. They actually assist in doing a lot of the design work for us up here. And what we do is we actually go and label and pre-configure every one of these units before it goes and is shipped from us. And we send out the drawings already done showing where every speaker goes. Because if somebody inadvertently goes and hooks up just the way they feel like hooking it up when they get to the site, and there's hundreds and hundreds of speakers, and they didn't put them where we asked them to put them, it can be pretty confusing. I get to a site and we spend potentially days figuring out where every speaker is because they didn't follow the directions. They took a build-it-yourself project and decided to really build it just themselves. Again, this is the software. These are your audio channels coming in, internal generators, again, by each speaker that's on there. So how do we decide which one to use? Uniformity, the 70 volt in the network, we normally send somebody out to every single job. We send a BOM out that shows tuning as a line item so that you know exactly how much it's going to cost to get the system to conform to the specification that you are looking for. The little tiny speakers that are directly facing, those are uniform out of the box. Again, the things that we always consider are the aesthetics. Does the architect not want something shown in the ceiling? Okay, that makes a decision for us. Installer qualifications. There are some people that are better at doing like pre-construction, real construction zone work, and there are better people that just do sort of retrofit type of work. And so we look at those sorts of skill sets. Commissioning, the most complex is the 70 volt systems, the least is for the QT. And the equipment cost, again, this is generally speaking, 70 volts always going to be your lowest cost. And this QT Pro, the direct firing, is going to be more expensive. Again, it always depends on the project. Some projects, just the fact of us coming out to tune a system is going to be more expensive than the rest of the project. So we have to think about that too. We also do eavesdropping. I know that there are no secrets in Canada, but if you do want to keep secrets, we do have systems that allow you to actually go and mask windows so that people can't shoot a laser beam at the window and hear what the people are saying by the vibrations on the glass. We can put things under the floor so that people can't listen from the floor below. We can put things on pipes, on HVAC ducts, and shake them so that people can't put a doctor's stethoscope up to the door or anything and to hear them that way. So we do a lot of government work, defense contractors, people that need to keep, pharmaceutical companies are always paranoid enough that they think that they need this in just about every place. Our company basically does all the designs. If you have plans, if you have prints that you want to get a bill of materials, find out what the cost is going to be, whether it's budgetary, whether it's a rough order of magnitude, whether it's a full finished design. We have people that will do the design for you. No fee. Normally what we do is we do have a design fee in the BOM for whoever gets the final contract. So we don't limit the number of potential bidders that would be looking at assisting you on a project, because that price is something that they see, that they know that they will have to pay only if they get the project. We don't charge everybody that's going to bid on a project a design fee because it's in our best interest not to. And we do normally 30 to 40 requests per day. We do up to 600 designs a month, something that most companies don't want to take on to do themselves. All that we ask is the right information. Again, if we get reflected ceilings, if we get floor plans, if we get interior elevations, if we get where you want the sound masking and where you don't want the sound masking. A lot of people put down on their descriptions that they want masking everywhere. And if you say that, you get masking everywhere. Where don't you want masking? You don't want it any place where you have to be able to understand what people are saying. You don't want it in training rooms. You don't want it in conference rooms. You don't want it any place you're going to be doing audio conferencing or video conferencing, because those systems pick up that masking noise and send it to the far end. It's not so annoying for the people in the room, but for the people that are in the far end, on the phone, and they're listening to a conference, and all of a sudden somebody speaks in the room, and all of a sudden, shh, gates on, gates off, gates on, gates off. So yeah, we try to talk you through some of the pros and cons of where you want masking. Big thing right now is music in bathrooms. Really easy to add to a system. Music in the lobbies, music in other places. Just to keep in mind. Single website access, just go and fill in the form, submit your documents all in one place. Tell us if there's anything specific that you need. If you are an acoustic consultant, we want to talk to you. We want to make sure that we are doing exactly what you want. If you want a different spectrum, if you want us to give you a specification document to provide with the bill of materials, we can do all those things for you. If you want all of the collateral materials, those are the things we can do. And anything that you know about the system that's going in. Does this client already use masking? Do they already have a type of system they prefer? We'd rather not design multiple systems if we already know that that's the system that they like. And the last thing is that we do have distributors here in Canada. They stock equipment here. They are, again, Technik Contact is a great representative and distributor for us. They assist with designs. They will come out. They will site survey with you. They will go and assist with problems. A really great resource here in Canada. And we are the only manufacturer that does every type of system, whether it's eavesdropping, whether it's in the plenum, out of the plenum, whatever. We try to make it really easy to just go to one place and get exactly what you need. Okay. I guess we are done. Thank you.